All right, guys. We're on. All right, section 8.2, parallelograms and triangles. I already gave you the area formula for a parallelogram right here. It's the area A of a parallelogram with base B and corresponding altitude H is the A equaling BH. Now, does that formula look familiar? Looks like which formula? Area of a rectangle. But that doesn't look like a rectangle. Looks like a parallelogram. But if I was to take this triangle and move it over here, now what does it look like? Looks like a rectangle. So that's why the formula right here for rectangle is the same as the formula for a parallelogram, because you could actually make every parallelogram become a rectangle by taking off this triangle at the end there and moving it over. So we have the same formula for a rectangle as we do for parallelogram. In my parallelogram right here, what do I need still so that I can find the area? I have the base, 9. I don't have the height. I need to find the H. Okay, I know my base right here is 9. That is a given. What I don't have is my H, my height. So what I need to do is figure that out. Now, there's a couple ways. SOHCAHTOA works. Why would SOHCAHTOA work? Because I have what kind of triangle? A right triangle. SOHCAHTOA only works when you have this kind of a triangle. So I could do the sine of 60 is H opposite over 6 hypotenuse, OH, remember, SOH, so we could do that. Or I could look and I could, wait a second, I got 60, I got a 90, so this must be 30. Do I remember my 30, 60, 90 little shortcut? My hypotenuse equals 2 times the short leg. So how do I get the short leg by itself? Just divide it by 2. So that means my short leg equals my hypotenuse divided by 2. Can I use that in this triangle? Yeah, divide the hypotenuse by 2. My short leg is going to be a 3. So my short leg is 3 centimeters. Do we remember how to get from the long leg or from the short leg to the long leg? The short leg times something equals the long leg. Radical 3. So my long leg is going to be the short leg, which is 3, times the radical 3. There's my height. Now I have it. I didn't even have to use SOHCAHTOA because it was a 30, 60, 90. Would it be wrong to use SOHCAHTOA? No. You can use it. You'll get the same decimal as you would when you get 3 radical 3. But that's just a little shortcut. So I would actually make sure I would put these on my paper just to review for myself, the 30, 60, 90, so I remember them. Now we want to find the area of this parallelogram. We know the formula is base times height. We know my base is 9 and my height is 3 radical 3. So my area is 9 times 3 radical 3, which comes out to be 27 radical 3 square centimeters. Could we make it a decimal if we wanted to? Sure, you could always make them decimals when you want. But a lot of times your answer is going to be left with a radical. So it's okay to leave it as 27 radical 3. As long as your radical is completely reduced. Yes? How much? Okay, did you take 27 times it by radical 3?
No, I took 3 radical 3, and then that equals 5.9.
Okay, good. 5.9 times 9, right? Base times height. Yeah, that'll be what you get there, same thing. If I got a decimal, I'm sure I get the same thing. So, all right, let's get to the next slide. Okay, here's an example number 1. If the area of the following parallelogram is 116 square feet, then what is the length of this VW, which is my altitude, or another word for that would be height, my H. The area is 116. So let's go to our area formula first. Area formula is base times height for that parallelogram. I don't know the height. They want us to figure that out. What do I know? I do know the base. What's the base? 7? 14.5? 7? 14.5? Which one is it? 14.5? 7? Do we know anything else? We do know the area. For sure, this area is going to go in for A. We know that's going to go in here, right? We just need to know which one of these two numbers is my base. Okay, well, let me give you that answer right now. It is 14.5. Could 7 have been a base? If I had a perpendicular line that went straight up and made a 90-degree angle, then 7 could have been a base. But it's not a base right now. Right now, the 14.5 is the base. These are going to cancel out when I divide both sides by 14.5. You're going to end up with your H being 8 feet. So this H right here is 8 feet. That was a parable 8. 8 feet. Okay, now, here's the question. Why was the 14.5 the base and not the 7? Why did we use TU right here as the base and not the ST? What do we know about every base and height together? They have to make a certain kind of angle. A base and a height have to make what kind of angle? 90 degrees. So what do we call two lines that are 90 degrees? Starts with a P. Perpendicular. A base and a height must be perpendicular. An altitude and a base have to be perpendicular. The altitude VW is not perpendicular to ST. It's not the base. Only the base and the height have to be perpendicular. TU is what's perpendicular to VW, not ST. TU. All right, next slide. Area of a triangle. Now, on your paper, you've only got one triangle. I want to show you where to draw your second triangle in, because I'm going to show you with two congruent triangles what we can actually do. And you can notice they're congruent, right? One goes right on top of the other. I'm going to take this first one, and I'm going to flip it in the x-axis. It means it flipped it up. Then I'm going to take that same triangle, and I'm going to flip it in the y-axis. And now I'm going to take my triangle, and I'm going to put it right here, and it makes what? A parallelogram. Two congruent triangles will make a parallelogram every time. What about if it's a right triangle? Let's do the same thing. I'm going to flip it around in the x-axis. Then I'm going to flip it around in the y-axis. I'm going to bring it down, and what do I make?
Square.
Not a square, a rectangle. It's got right angles.
Is it the same thing?
Okay, so what can we make with two congruent triangles? A parallelogram or parallelogram or square. I mean rectangle.
It's really, I thought of rectangle.
No, a square is a rectangle. A rectangle does not have to be a square. A rectangle just has to have right angles. A rectangle that's really long and skinny, you can't tell me it's a square. A rectangle is not always a square. A rectangle is only a square when they're the exact all four sides are the same and you get right angles. Okay, so here's the formula for area of a triangle. Area of a triangle, area A of a triangle with base B and corresponding altitude H is base times height divided by 2. We already have seen that formula many times, but just putting it out there again so you can see it. 1/2 times base times height this also works, because 1/2 is the same thing as dividing by 2. You multiply by 1/2. But what did we learn from this picture right here? What's the area of a parallelogram? Area of a parallelogram. Base times height. What's the area of a rectangle? Base times height. Well, how do I get this triangle out of that rectangle? I just got an half. So I take my base times height, right here, my base times my height, and I cut it in half and I have a triangle. That's where this formula comes from. It's the fact that two of them make a parallelogram or a rectangle. And you could cut it in half to get the triangle. So you should draw in your other triangles and then show that that's how it works. That's what this statement says right here. The statement's basically saying that since the area of a parallelogram and rectangle are both base times height, then the triangle is exactly half of the base times height. So each triangle is half of the parallelogram or rectangle that we just made over there. So it's half of base times height. The area represents half of base times height. Okay, let's move on. Example 2. All right, this is a good one. You need to really focus on this one. What is the area of a right isosceles triangle with a base of 130 centimeters? So first thing I want you to do is picture a right isosceles triangle. Right isosceles. Okay, remember isosceles has two equal sides. Right isosceles, though, has to have a right angle in it. Where would the right angle need to be if the two equal sides are like this? It have to be on the top. You have to have your right angle on the top and your two equal sides. So first thing I would want to do is I'd want to draw my triangle. Right angle on top, these are my two congruent sides right here. Now the bottom two angles would have to be what? They have to equal each other, and they have to add up to 90. So yes, they have to be 45 degrees. So whenever you see the words right isosceles triangle, the only option is a 45, 45, 90 because you got your two equal sides with your two equal angles. Your two 45s make your two equal sides. So it has to be a 45, 45, 90 to be a right isosceles triangle. What we need to do is find the area of it. We know the base is 130. Now I want you to look at something for a second. I want to highlight this triangle right here. Okay, do you see that triangle that I just darkened in a little? What do you think about that triangle? The exact same as the other one? Yeah, the two are the same. What else? What kind of triangle? It's a right isosceles triangle again. This is also 45 up here. Because this is 90, this is 45, so this had to have been 45. That means that this leg equals this leg. Why is that important? Yeah, that's my height, right? Half of 130 is going to be this piece, and it's going to be my height. It's going to be down here, and it's going to be here, which is 65. Now I know my height already. I didn't need to use anything else. I just knew that 45, 45, 90s have equal legs. Both legs have to be the same, and this is also a 65 right there. These are both 65, that's a 65. So how do I find my area now? You don't need to use the Pythagorean theorem, but you could. I think the better choice is to do what I did on this second one right here. Pythagorean theorem, if you would have made both of these x squared plus x squared equals 130 squared, it could give you sides and then you could get the height, but we didn't need that. What we wanted, we could use is the 45, 45, 90, which would be a little easier for us. The altitude is 65, since these two are both 65s, and these are 45, 45, 90s inside. Therefore, the area would be your base, 130, times your height of 65, and then divide by 2. So 130 times 65 divided by 2, you get 4,225 square centimeters. Square centimeters. Yeah. 65 for the middle. Because this is a 45, 45. That means these two legs are the same. And then they're both 65. Okay, quick number stumper. All right, 8S on an SS was 8 sides on a stop sign. That's good. No, octagons are a stop sign. All right, let's look at the next one. Perimeter of an equilateral triangle is 63. Okay, so in your mind, picture equilateral triangle. Okay, all equal sides, 3 sides equal. Okay, if the perimeter is 63, each side has to be how much?
It
would be 21. Each side would be 21. Okay, so what we're going to do is we're going to draw the triangle. Okay, we know that each side is going to be 21. So I'm going to actually put that, 21. 21 on all 3 sides. Okay, now the perimeter is 63. Therefore, each side would be 63 divided by 3, which is 21. That's why I put those in there. Since the triangles inside are 30, 60, 90, how do I know that the triangles inside are 30, 60, 90? What do I know about all 3 angles in an equilateral triangle? They add it to 180, but they are all the same. So what's 180 divided by 3? They're all 60 degrees. 60, 60. And what did I do to this top 60? I cut it in half, and I made 2 30s right there. So yeah, you've got a 30, 60, 90 triangle inside. If you look back at the very beginning of our notes, we did some little 30, 60, 90 stuff. How do I get from the hypotenuse to my short leg? Divide by, good, divide by 2, 10.5. So my short leg is 10.5. This one's also 10.5 because what do these two have to add up to on the bottom? 21. So they have to both be 10.5. How do I get from my short leg to my long leg? Times it by radical 3. So 10.5 radical 3 is going to be my height. That's right here. So since they're 30, 60, 90s, the short leg is 10.5. The longer leg then becomes 10.5 radical 3. Therefore, my area is going to be the 21 is my base. Here's my B. Here's my H. Oops, that's not a good H. Here's my H. Base times height. And then I divide it by 2, and I get approximately 191 square inches. So I can take the perimeter of an equilateral triangle, use that information to find this area of that same triangle. Going from perimeter to area, we just needed the sides and the height. Once we got that, we can figure out the area of the new triangle, or of that equilateral triangle. Okay, so we've covered parallelograms, we've covered triangles. There's one last one that we need to cover, and that would be a rhombus. So let's take a look at a rhombus. Okay, a rhombus. Now this is important. Underline this. A rhombus is a parallelogram. It has perpendicular diagonals. It has congruent sides. Those things you've got to know about a rhombus. You must know those about a rhombus. Now, to get the area for a rhombus, to get the area of a rhombus, you could use 2 formulas. You could use area equals base times height. Now, base times height is the formula for which other shape? Rectangle or parallelogram. Since the rhombus is a parallelogram, you could use that formula. It works. Because a rhombus is a parallelogram. This formula is okay to use. Base times height. If you know the base and you know the height, then use it. That's the formula for area. But you could also use diagonal times diagonal divided by 2. And that's because of the perpendicular diagonal. That formula works whenever you have perpendicular diagonal. That formula works for a kite. A kite has perpendicular diagonal, so it would also work for a kite. So rhombus, you really have two formulas that you could decide to use. Either one works. Now, true or false? A square is a rhombus.
Oh, right. That's true.
Sure.
Man, you said everything's a
You just
square.
told us that
You
earlier.
said everything's a square.
Correct. A square is a rhombus.
Don't get extra.
A square is a rhombus. That is correct. A square is a parallelogram. A square has perpendicular diagonals, and a square has congruent sides. So yes, a square is a rhombus. It has all three of those things. So that's why I can go down here, since I'm talking about a rhombus, and I can say find the area of a square, because a square is a rhombus that has a diagonal of 4 centimeters. Okay, so here's my picture. I got a square, I drew in a diagonal, got a 4 centimeter length. Could I find the area of that without doing much work? Probably could. I probably could because of this formula right here. If I take this formula and apply it to this problem, what do I know here? I know that if one diagonal is a 4, then what's my other diagonal going to be? It has to be 4 if it's a square. And since both diagonals are the same, in a square, both diagonals are the same, therefore, 4 for one diagonal times 4 for the other diagonal divided by 2, you're going to get an area of 8 square centimeters. So if you've got a square that gives you the diagonals 4, then you know automatically that the area has to be 8 square centimeters. So if I had a square and the diagonal's 10, what would the area be?
I got 50.
50, good. It would be 50. You square this and then cut it in half, because you got two of the same diagonals. Square it, cut it in half. So 10 squared would be 100, divided by 2 would be 50. What was the one you missed?
One on homework.
Oh, the most important one, huh?
Do I get extra for the
All right. All right, let's go to the review problem real quick. Let's see what this one is. Find the measure of angle ACD. This was way back in chapter 1. Could we find the measure of angle ACD? What would it be? Good, 148 is correct. How did we get that? How come this is 148 degrees right there? Well, vertical angles would be here or here, but what do we know about this line right here? It's 180 degrees. It's a straight line. Every straight line is 180 degrees. So these are called supplementary. They're called a linear pair because they're a pair that makes a straight line. They're adjacent because they're touching. They're all that stuff. What if I had said solve for x? That's what I meant to say. I messed up and I put find angle ACD. I meant to say solve for x. What would you have to do to solve for x? 32 right here. So these three together have to add up to. So what's 2x plus 3x? 5x. What's 9 plus 14? 23 plus 32 is actually 55. Equals 180. When you solve it, you would end up with 25, just as a side note. There, just in case you needed to know how to solve for x, because that might be something that you will have to do is solve for x.
This problem's not on the paper.
Give me that. I know you draw it.
Oh. You didn't say
The
that.
review ones you draw.
You never said that.
I always said that last time.
That was last
Those are
time.
the ones you got to put on your paper. Here we go. Okay, next. Find the area of the rhombus. Okay, which formula are we going to use on this one? Well, saving a little time, we are going to use the diagonal formula. Because the diagonals are given to us right there because they're horizontal and they're vertical and they're easy to count. You can count from A to C is 8 and from B to D is 12. So you can basically use the diagonal 1 times diagonal 2 divided by 2. You're going to get 8 times 12 is 96 divided by 2 and you get 48 units squared. So that one was a pretty quick one. Just wanted you to see how you might solve for that one. That one you definitely want to use the diagonal formula because they're very easy to count. You can't really, I mean you could, it would take a lot of work to find the base and the height of that rhombus. You'd have to find one of the sides by using the distance formula and then find a perpendicular line using slopes and all that other stuff. It would be challenging. So there's your rhombus. Okay, we're done with that one? Almost? Okay, moving on to the last one. There's just like 4 little practice ones. 3 of them are really fast. One of them takes a little longer. 3 of them are really quick. So let's look at those 4. What 2 numbers do I need to use to find the area of that parallelogram? Be careful. What 2 numbers are going to be the ones I need to multiply for number 1? Oops. Ah. Okay, number 1, I'm going to use the 3 and the 6 only. Here's my base, because there's my right angle, and there's my H. So 3 times 6, you're going to get 18 square centimeters. What 2 numbers do I need for this one? And be careful. 6 and 14?
6 and
No, you need 14.
What's the base of my triangle? 12. What's the height of my triangle? 6. And divide by 2, you're going to end up with 36 square inches. Now what is this 2 there for then? It's just to show you that you need to make sure you come straight down, and that's 2 inches away from an obtuse angle. The only way you can get an obtuse angle or obtuse triangle to have an altitude on the inside of the triangle is if you do it in here. If you're going to do it from one of these other ones, you're going to need to bring it down like this or down like this or something to get a 90-degree angle. So that had to be 12 and 6. That's your base and your height. Divide by 2, you get your 36. This one right down here, number 4, we could draw in a rectangle and a triangle. What's 30 times 40?
120.
1200.
1200. Thank you.
Oh yeah, there's 2 zeros.
1200. You got 2 zeros. The 30 has a 0 and the 40 has a 0. So 1200. And on this one, you're going to have a 30 times a 40 again, but this time you got to do what to it?
Divided
Divide it by 2.
600.
So this one's going to be 600. So 1200 plus 600, 1800 square feet. Number 3 is our last one here. We have this first triangle, we have the second triangle. What do we know about those 2 triangles? They're right triangles. They're both congruent to each other. They're right isosceles. That means they're what kind of triangles? 45, 90s.
Various 50.
What if I took these 2 triangles and put them together to make a square? Oh, what would the dimensions be? 3 by 3, so what's 3 times 3?
9.
Cut it in half. They're both 4.5, right? This is 4.5. Base 3 times 3 divided by 2 is going to give me 4.5 for my area. Now, what is my height?
It's 6.
Oh.
Because it's a triangle.
Not a square. This is 45, 45, 90. You remember in the 45, 45, 90 family, your hypotenuse equals the leg times radical 2. What's my leg? 3 is my leg times, this is going to be 3 radical 2 here. So you're going to get 6 times 3 radical 2, which is 18 radical 2. So your area is 9 plus 18 radical 2, which is about 34.5 when you find out the decimal value of that right there. All right, find the area of each rhombus. The first one, the area of this rhombus, they're giving us the base of 12, and they're giving us the height of 8. So this one, your area is just going to simply be base times height, which is going to be 12 times 8. Area is 96 square feet. Now this rhombus down here, you could extend this diagonal out, you'd have another 5 because diagonals bisect each other. So these pieces are equal.
Oh,
No, it's okay. I'm just trying to. So you've got your diagonal 1, which is going to end up being 10. You've got your diagonal 2, which is a 6, which they gave us in the problem. 6 right here. This whole thing was my 10. My two 5s together make 10. So 10 times 6 divided by 2 is going to be 30 square meters. So you had your 60 divided by 2 gave me 30. Parallelogram, vertices of 3, negative 2. Over 3 down 2. Over 9 down 2. 2. Over 12 and up 4. Over 12, 1, 2, 3, 4. And 6, 4, 1, 2, 3, 4, 5, 6. Alright, there's my parallelogram. Okay. Let me finish this real quick. So let's go over let me draw this in. There's a rhomb. That's a parallelogram. Might be a rhombus, depending on if they're all sides the same. Let's find the perimeter and the area to the nearest 10. So perimeter would be to add up the sides. So let's see. We've got 1, 2, 3, 4, 5, 6 across the top. Means we got 6 on the bottom. We could use Pythagorean theorem here to get this side, or we could use distance formula. You'd go over 1, 2, 3. Here'd go up 1, 2, 3, 4, 5, 6. So 3 squared plus 6 squared equals c squared. 9 plus 36 would be 45, not 47, sorry. Nine plus 36 would be 45 equals c squared, so it's square rooted. Radical 9, and it's going to be 3 radical 5. That's going to be this length here. 3 radical 5, and another 3 radical 5. So your perimeter would be 12 plus 6 radical 5. All right, we got the perimeter, which was 12 plus 6 radical 5. To get the area, we can just do base times height. So in this one, you've got 6 for your base, and you've got 1, 2, 3, 4, 5, 6 for your height. Your area would be 6 times 6, which is 36 square units. All right, this last one we will do in class. So you can leave that one blank on your notes and bring it to class. We'll do that either Wednesday or Thursday.